Hello. I kind of screwed that up there a little bit, but it's been a long night. Believe me, I've been fighting with my setup here a little bit tonight. Uh, Trying a few new things. Like I said, trying to increase the production value here. I shouldn't say. I guess I shouldn't say production value. Yeah, there goes tonight's grip. But more of a trying to get today's increase the production level. I guess it's what we're looking at. So once again, I skipped a couple of weeks without doing any recordings, and I do apologize for that. But things aren't exactly getting easier at work. I thought they'd be getting better, but they're not. Um, so anyway, moving along. In this episode, we're going to take a look at something a little different. The past few episodes, we've been mainly focusing on things like things like firewalls and routers. Today, I figure I'm going to try something a little different. We are going to talk about some network services. More particular, we are going to talk DNS and DHCP. Now, I'm hoping to make this video pretty short. It is late at night. It took me an hour and a half to get my setup working properly to the point where I think I can get a good show for you. I know the audio is a little weird and there's still a little bit of a background noise in there. It's ground noise. I need to figure out where that ground noise is coming from. But in the interest of just getting a show out here tonight, let us just go with it. So let's kick it off. DNS. All right. So what's DNS? Well, DNS started back in the early days of computing, around the time of the early Unix hosts. And in the beginning, there's literally a file called etc hosts. Well, actually, it's called hosts, and it is in the etc directory for Unix, or I should say POSIX-based operating systems. So that'd be your Linux, Mac OS, and Unix-based distributions like FreeBSD and things of that ilk. Basically, the idea was is you would put a short name followed by, say, an IP address, and this would help you resolve your host without having to memorize a bunch of IP addresses. It was such a good idea that even Windows more or less copied it. And so this is a copy here of my etc host file from my Wi-Fi controller. As you can see, there's not really much in there. It does come with some default stuff in there. Now, I know a lot of people like to blur this stuff out, but whatever. I mean, if someone is really targeting me for a hack, they're gonna find a way in, right? So, showing something like this, I'm not really afraid of it. But as you can see, it says Wi-Fi, right, which would be a short name, and it also says Wi-Fi.home.local. Now, home.local is just my local domain. I run my own DNS servers. Are you surprised? And this is the Windows equivalent. It's in a slightly different directory. It's under Windows System 32 drivers, etc, and hosts, and it's relatively similar to the one that you would find in POSIX-based OS. And they make sure to give you some helpful examples on how you can do that. So there you go. That's kind of what it looks like. So now this stuff worked great in the beginning, right? And the network where you have 3 or 4 hosts, mainly servers or like a print server or something of that sort. It was perfect. You know, it was very easy to address things. But then the internet happened. So I guess let's get into things a little bit. So what does DNS mean to begin with? Well, officially it stands for Domain Name System, but you also commonly hear people say Domain Name Server, and Domain Name Server actually refers to the actual box that's doing the resolution. So just like the host file converts host names to IP addresses, so does DNS. And it actually does it in the opposite direction too, which is an IP address to a host name. So now this is technically really just a convenient service, right? You don't really need it to do things on the internet. So if you know the IP address of google.com, then you can gladly just go to that IP address and it will resolve. And you will hit the server. I shouldn't say resolve. Resolve is DNS. It will hit that server and you'll pull up Google's website just fine. In fact, this is a common workaround for a lot of people in enterprise networks where you may be behind a proxy server or some sort of web filter where they want to, say, limit their employees' access to Facebook. So what you would do is if you, say, go home and you get the IP address of Facebook, you can simply just put that IP address in and basically you can hit Facebook's website. Now, there are a few caveats that I probably should have tested. In this day and age where we're using things like server name indicators, the web servers actually depend on the incoming request to have the name of the server that you're looking for. But in the case of something like Facebook or Google, you're probably pretty safe just using the IP address, because I highly, highly doubt that they're hosting more than one site out of the same IP address. But another quick thing here is it's local, right? So it can be overridden. So if we go back and we look at my entry here, you see it says homenet.local. So that means anytime I type the IP address, or I should say this, every time I type Wi-Fi.homenet.local within my home network, everything in here knows how to get to that, right? Because it always points to that device. Now, I didn't have to name it Wi-Fi.homenet.local. In fact, I could have named it Google.com and put the IP address of my wireless controller, and it would resolve to that, right? Just in the host file, but I could also do it in my DNS server, which is actually kind of a little funny little prank, because you can actually do this to any computer, and you can say, for example, make google.com resolve to Goatse or Rickroll or one of those, whatever, insert your meme here. But moving along as fast as I can go here, it's not strictly needed, but with the millions and millions of websites on the internet, try using the internet without it. So one last thing, it is based on text records, right? So the basic ones are the A record, right, or for IPv4, and IPv6. It's a little variation on the A record. An A record resolves a host name to an IP address. So Google.com will resolve to an IP address, right? The next one down is a canonical name. So canonical names come in pretty handy. So, for example, you can have a server that the official host name is, say, blog.google.com. But instead of going to blog.google.com every time in your browser, you can have a record that says ryanjones.com is the canonical name for blog.google.com. So every time you type ryanjones.com, the DNS server sees that you mean blog.google.com, and we will resolve to that. Now, also, because it also has the A record in there for blog.google.com, it will also know how to get there. It's a bit of a treat. The other one that's pretty standard is a pointer record. That's what the PTR there is, and basically that just does what we call reverse lookups. So you put an IP address, and it resolves back to your DNS server, and it looks up the IP address that corresponds to that host. There are a couple other specialized ones like SPF, which deals with certain kinds of mail security. Basically, it's how your mail server tells the rest of the world that you're not going to spam. And finally, there's an arbitrary text field, which can technically contain anything, which is why it's called text. So, DHCP. DHCP is the Dynamic Host Configuration Protocol. It is another convenience service. Basically, what it does is it automatically assigns IP addresses. Well, I say IP address, but it can actually do more than IP address. So basically, it gives a client everything that it needs to know to connect to a network. So that will be the IP address, the subnet mask, the default gateway, the DNS servers, when you look at that, and any other information that you may need. So say this is a fresh box with no OS on it, and you want to do a network boot to install an OS, you can have things like the next server record, which will say, hey, this server at whatever the IP address that you want to put in there contains all the information you need to install an OS on your hard drive, right? And that's how you do things to automate OS installs. In fact, businesses will do this a lot, right? If you think about it, a business will buy 1,000 Dell PCs, and they don't run the standard Windows install that comes with that PC. They have a special customized version, which is basically they install it on one PC, they install the software that they want, they tweak the settings, they save this as a disk image or an identical copy, and then they put it on with, for example, a Pixie box, or I think Windows has this Windows deployment server or services. I don't remember the actual name of it, and basically you create a host record that says DNS. Oh wow! You create a DHCP entry that points to this server. So when a new computer boots for the first time, or actually not even for the first time, so you can actually force it by, there's usually like a key, like a F12, to basically to trigger the network boot. It goes to that server, it downloads the files that it needs, and then it installs the OS. And then on the next boot, if it's assuming it's configured correctly, it would just boot straight into Windows. Now, you don't need a DHCP server. You can actually put all this information in yourself manually, right? If you have 1, 2, 3 computers in your house, you don't need to run a DHCP server. You can just go to each computer and put the information in. The convenience is when you have the DHCP server, you don't have to do any of that. Think about it. Lots of people buy a router from Best Buy, and they never actually log into it to see what's going on or to tweak any settings, which is actually a bad thing, people. You should never do that. You should always do things like change the default password, etc. But when you plug your laptop in there for the first time, you just bang automatically. You just see this IP address, 192.168.1. Whatever, right? That's how you get that. That is the DHCP server running. So who else uses this? Well, ISPs will use this. If you don't have a static IP address, meaning that you go into your router and actually put in the IP information that the ISP will typically assign to you, then you actually get your IP address from their DHCP server, which is typically the same as the one you'd have in your little blue box router, except it's probably running on some beefier hardware. And it basically does the same thing, except it hands out internet-based IP addresses, or I should say public IP addresses, versus the private IP address, such as 192.168.1.3 that you would typically have in your house. It's also a must for large networks, right? Like I said, if you're in your house, you have 5 hosts in your house, and you can go about to each one of those one at a time and make that change. The problem would come, for example, is if you have visitors come over to your house, they connect to your Wi-Fi, they can't do anything. You have to go to their phone or their iPad or laptop, and you'd have to manually make that change. You'd have to manually put that information in for them. And then the gotcha there is that since you set it to static IP, when they go to someone else's house or their own house, where they don't, they'll be stuck basically with the settings that you put in last, and they would either have to switch back to DHCP or do the same thing, enter the information statically. So you can see where DHCP comes in pretty important. Now, if you have 50 hosts or 1,000 hosts or 6 million hosts, I mean, think about service like AWS, right? They are constantly spinning up and down servers for customers, right? EC2 instances. Those servers magically get an IP address when they come to boot. And how do they do that? They're assigned through a DHCP server. Now, as usual, I like to give a bit of some practical examples. So in this case, what I did was I just took a couple screen caps from my localized DHCP server running on my Wi-Fi controller. So you can see I have 35 clients on active at the time I took the screenshot. Don't ask. And this is what the typical list would look like if you list them in the list view. You can see it gives a lot of information here, but the important things would be things like the IP address and the client. There was a way to filter things like there was a way to filter things to show more information, but I want to keep this as simple as possible. And this is showing not just Wi-Fi devices. This is also showing hardwired devices, such as the PC that I'm recording this on. Anyway, after a long and trying night, trying to get things all set up and working properly, I'm going to end this video here. I don't know what my next topic is going to be yet, so I'm not going to give you a teaser about it. But until next time, this is Ryan, and see you guys next time.